bisectors and perpendicular bisectors, this really should not be new to you, okay? We've constructed them, we've worked with them, we've defined them in our book. Nick, get the electronic device out of your ear, please. And so this is just kind of hitting that again with a different looking picture, okay? So before we look at the bisectors in particular, let's talk about the distance from a point to a line. And in order to do that, I am just going to draw a picture. Here is a point, okay? And here is a line. And if you want the distance between them, you want the shortest distance between them, okay? And so what you want to do is draw a line that is perpendicular from the point to the line. That is the distance between the point and the line, okay? So if you drew something like this, yes, you're connecting the point and the line, but it's much longer. This is not what we want.
So it has to be perpendicular?
Absolutely. Yes, it has to be perpendicular so that that is the measurement between the point and the line. It's the shortest distance. Okay, what does equiangular mean? All the angles are equal. What does equilateral mean? All the sides are the same. What does equidistance mean? All the distances are equal, right? So equal distances. Whoa, I spelled that completely wrong. All right. And perpendicular bisector. Talk to me about perpendicular. Right angle. Talk to me about bisector. Cuts it in half. Okay. So it is a line, segment, or ray that cuts a segment in half, essentially, or bisects, at a right angle. So basically it goes through the midpoint, right? What?
Is that sides?
A line segment array that cuts a segment in half. Mm-hmm. So if I had a segment and I had a bisector, it is perpendicular and it cuts it in half. An angle bisector is? An angle bisector, since bisector means cut in half, it just cuts the angle in half. It makes two congruent angles. But what this is saying is if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. And the heat is kind of all or nothing, so it will warm us up and then it'll kick off, so we'll feel like we're smothering, and then we'll cool down and it'll just be a vicious cycle still. Okay, so it's equidistant from the two sides of the angle. So if we're given that first picture, AB, ray AB, is an angle bisector because it's congruent on either side. Okay? So what it's saying is if you put a point, say B, somewhere on the angle bisector, it does not matter where, it is going to be equidistant or an equal distance from this side and this side. Those distances are going to be the same. So basically, if I walk down the center of the room from corner to corner, I am the same distance from the right side as I am from the left side. That's what that's saying. Example 1. In the diagram, ray UW bisects angle TU. So before we go on, I'm going to mark that, okay? So since UW is an angle bisector, it means that this angle is congruent to this angle because it cuts the bigger angle in half. Then it says angle UTW and UVW are right angles. Those are already marked for us. Perfect. Now it says to prove the triangle's congruent. We have 5 ways to prove triangles congruent. What are they? Side, side, side. Side angle, side. Angle, side, angle. We've got side angle, side. Angle, angle, side. Hypotenuse, leg. Perfect. And in order to do a proof, we need 2 columns. We need statements. We need reasons. And what's the very first thing we put in our proof every time? Givens. Do it. Anything that you mark in your picture, you should also write in your proof. So we marked these angles congruent. So I'm going to go ahead and put step 2 in here. Angle TUW is congruent to angle VUW. Why were we able to mark those congruent? How did we know those were the same? We had a bisector, right? Angle bisectors cut in half, to put it plain and simple, or make 2 congruent angles, cut the larger angle into 2 congruent angles, something along those lines. Okay, we want to prove triangle TWU congruent to triangle VWU by one of these methods. Right now, we only have 2 angles. So looking at our options, we're not going to use side, side, side. We're not going to use side angle, side. And we're not going to use hypotenuse, leg because none of those have 2 angles. So now it's our job to see if we can get another side to use angle, side, angle, or angle, angle, side. Question? Answer? Okay, do you have the answer on what piece we can get next? Okay, what can we get congruent to? The reflexive, that's exactly right. Okay, so we've, WU is congruent to itself, right? WU congruent to WU by the reflexive property. Good.
I have a question.
Yes.
How could that not be HL?
Okay, how can that not be HL? Because we only have the hypotenuse, we don't have a leg. Does that make sense? Now, you could put the leg in there. You could say WT is congruent to WV because W is equidistant from the sides because it's on the angle bisector. But we didn't put that in there, so we're not going to use that one. But you can. Angle, side, angle, or angle, angle, side? Is the side between the angles? No, so it is
AAS.
angle, angle, side. Beautiful. All right. Perpendicular bisector theorem. Again, you already know what a perpendicular bisector is, but this is going a little bit further. If a point is on the perpendicular bisector, like the point C there, then it is equidistant from the endpoints of the segment. So that means that this is congruent to this. These distances are equal. So CA equals CB. So if you look at example number 2, it says use the diagram to find segment or to find the length of AB. You have a perpendicular bisector. A is on the perpendicular bisector, which means that it is equidistant from D and B. Equi means equal. So those sides are equal. And then you can find the value of x by solving that equation. So what would we do? How would we get x by itself? Yeah, subtract 5x from both sides. And then what?
Divide by 3.
Divide by 3,
4.
and we get x equals 4.
So would that be A then? 4.
4 is x. So if I plugged in 4 into the x, I'd have 5 times 4 is 20, plus 10 is 32. So the length of DA is 32. And 8 times 4 is also 32, so the length of AB is also 32. That's what we're showing here, that those sides are equidistant. So the distance from H is equal from H to F and H to G. In number 2, the distance from M to L is the same as from M to K. And in number 3, the distance from F to E is the same as the distance from F to G. That's why we set those equal to each other and then solved them.
So you don't plug the 2 back in like you did the problem before?
I've only found x, but now we do have to look here and it says find FH. So if I plug back into FH, that would be 2 plus 3. So FH is actually 5. So GH would actually be 5 as well because they're equal. Here we want MK. So if x is 5, we'd have 5 plus 15, so 20. And here we want EF. So if x is 5, we want 2 times 5 plus 5. So we'd have 10 plus 5 is 15. Okay, so we have our givens in there, and what we want to work toward is that triangle MST is isosceles. And in order to be isosceles, what has to be true?
Yeah, I had 2 of those.
2 sides of the triangle are congruent, so it would be the legs. We want to try to get these 2 congruent. That's going to be our goal. So the step right before that is to show that MT is congruent to MS. But before we could show that their parts are congruent, we have to show that the what are congruent. If what are congruent, then the parts are congruent. What did we learn? If the triangles are congruent. So let's prove the triangle's congruent before that. We don't know what our reasons are yet, but we will fill them in. We're just kind of putting down our groundwork of where we need to go with this. We know our beginning, we know our end, and now we just have to fill in the middle. To show that the triangles are congruent, we have to have one of those 5 theorems: side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Right now, we have 2 pieces of information. We have a side and we have an angle. What's the easiest thing to put in our proof right away? The reflexive property, right? So let's put in MN congruent to MN by the reflexive property. Is that enough to show that the triangles are congruent? Remember, this is also right. Also, if one side's right, the other side's right. So is that enough to show the triangles are congruent? Yes, by side, angle, side. Because there's 2 sides with the angle between them. So MT congruent to MS, why? We don't have that marked, but we know if the triangles are congruent, Their parts are congruent. That's right.